Welcome all for this Scada training organized by Niwe, National Institute of Indian Energy. I really want to thank Dr. Kanagavel who extended this opportunity to me, which helps me to share my knowledge and learnings in this forum. Brief about myself. Kudiyarasu. +18 years of experience in automation industry and renewable sector. I started my career as an electrical engineer. Then I transformed as an embedded system programmer and worked for 2 embedded product design and development company as a programmer and lead programmer. Then I joined into another automation and remote monitoring products development company, and I lead a development team there. There we developed so many embedded remote monitoring products and IoT products. And in 2016, I joined in the Pioneer renewable energy company in Chennai to lead the solar Scada development. And currently I am working on the same organization. There I am heading the wind and solar technical support. And today's content for this training, which we are going to see the below topics: introduction on basics of Scada, what is the Scada architecture, and developing a new wind farms and implementation of Scada in the wind farms, functionality of the wind farm Scada that we are going to look into detail, and how we are managing the wind farms using Scada, like how we locally managing the wind farm and how we are locally remotely managing the Scada. And next, the Scada, how it is centrally connected and how it is monitored from central monitoring system, CMS system, right? So what are all the analytical methods which available using this Scada data? And the next one is the open protocol interface for external world data accessing, right, and the cloud protocols. So what is the latest technology in the wind Scada currently, that we are going to discuss about that. So, and finally the question and answer sessions. So I am just getting into the contents, right? We'll see what exactly the Scada. So the basic introduction of Scadas, right? As we know, it is an abbreviation of supervisory control and data acquisition, that is called Scada, and it consists 3 key elements, right? So as we know, monitoring is the first key element in the Scada, and control is the second one, and data logging is the third one, right? In case of wind Scada, it is used for remote and local supervision of wind turbine as well as wind park, right? You can monitor both the wind turbines, or you can, if you want to monitor in the park level from the central, that is also possible. So that's why it comes under the monitoring. So then it is nothing but it is a combination of telemetry and data logging, right? That is a key point here, right? Not only the supervision, and it access the data and fetch the data to the remote locations, as well as data storing. That is a key functionality, right? Finally, Scada is not just a hardware, neither a software. It is a concept and it is a process actually. It is a combination of hardware, software and protocols. It's everything binded together, that is called SCADA, right? So then we'll get into that what is WinForm SCADA architecture, right? How a normal WinForm SCADA, what is the basic architecture of WinForm SCADA? See, in case of this SCADA, just I'm selecting the marker here, laser pointer, so that might help. So this is the lower level, right? So WTGs, which is the level 0 in the SCADA architecture, right? The second level of data acquisition and the edge servers are the second level, level 1, and this is a central monitoring and forecasting. They are all using the data. They are not do any collection here. They are using the data which is available in the SCADA server, right? So in the later slides we will see how this is physically connected, how the turbines are physically connected to the SCADA, right? How the fiber communication and RF communication, which is coming in the later slides, right? So if you see the animation wave, so all the data will be pulled from the SCADA data acquisition layer. So in the SCADA, each and any SCADA server, data acquisition is the one of the key engine which take care of the SCADA communication from the turbine to SCADA, right? So this communication protocol may be different from OEMs to OEM, right? Some OEMs, they may use the OPC as the communication between the PLC, which is situated in the WTG, to the SCADA server, and somebody they are using the Modbus, right? And some of the OEMs, they are using their own customized protocol to enable the communication between the WTG, the data acquisition layer. So once data acquisition has been completed, then this DAQ layer is responsible for pushing the data into the databases, as well as this share the data in the OPC for the external world communication, right? So we normally know the OPC is the only communication which is having all the WTG data for the external, like customers or forecasting agencies or the central monitoring system team. Everybody using this OPC data, and this is highly reliable and as well as highly accurate, because the quality QoS is implemented here in the OPC protocol, right? This is the overall view, and most of the SCADA servers having some edge server for additional functionality, like sharing the CSV data to the forecasting agencies and sharing the data to the customer analytics. So there will be some additional server, because people, they don't want to increase the load of the SCADA server. That is the purpose here, right? So I hope you will have a bit clarity about how the architecture layer 0 and layer 1 and layer 2. So in latest slides we can have a detailed about how the layer 1 is connected and layer 2 is connected. We have the follow-up slides, right? So then we'll see how the new sites get implemented with the SCADA, right? So any new WinForms which is going to commission, so there are few steps which we usually follow to install the WinForm SCADA. The first and foremost step is the contractual requirement analysis. This is the basic step that is in a level 0 here. The first and foremost step, right? We need to go through the contract. Based on the contract, what we have agreed and what we supposed to deliver to the customers as well as the regulatory agencies. These contractual requirement need to be analyzed, and that needs to be noted down for the further study, right? First we take the contractual requirement and operational requirement. Second, one of the key challenging part here in the SCADA communication is SCADA implementation is SCADA communication, right? So since we know all the wind farms are in the very remote locations, there the main SCADA communication from the turbine to the SCADA is one of the big challenge, and internet communication to that wind farm itself another big challenge, right? These are all the two key areas we need to work on first and foremost. The second case, we'll send our survey engineers to make a survey how we can enable the communication between the turbines and the SCADA communication. So very prominent way and very reliable ways connecting the OFC between the turbine to the SCADA is the reliable way. So in case of challenges, right? In case of challenges in connecting the fiber cable, there we may go for the RF communication. That study will be made by this survey engineer, and he will suggest the feasible and reliable communication method, right? So that will be in the second phase, and third will be the internet communication, right? So even if it is all the communication are locally available with the help of fiber, we need to have an internet communication to get those data to the central monitoring station for analytics and the troubleshooting purpose. For that internet, the last mile connectivity is very much important. That we usually do that through portal first. Later we will send those details to the internet service providers. They will do the feasibility study. So based on that feasibility study, we'll decide which service provider is feasible, which reliable service provider is feasible. So these studies will be made on the third step. Based on all the three steps, we'll prepare the bill of material for this SCADA development. What kind of materials need, whether we need fiber or RF, whether we need to go with a reliable internet lease line connection, or we need to go for a VSAT connectivity. If in case of challenges in the internet, then we might go for the VSAT connectivity. And the SLDC communications, what are all the feasible methods? So these requirement has been analyzed, and the bill of material is prepared. Once the bill of material is prepared, then this will be sent to the technical approval. This design draft will be sent for the technical approval. Once the technical team approved this draft, then we initiate the procurement, right? So once material comes, we'll start the hardware assembly in our assembly area, server assembly area. Once physical hardware assembly is done, then hardware preparation will start it, because as we know, these are all blade servers. We need to do the hardware configuration and RAID configuration, OS configuration. These kind of hardware preparations needs to be done as the second phase, and we need to go for a SCADA programming. That is in the fourth phase. So then we have a usual image. That image will be installed, and the wind farm specific parameters and templates needs to be updated. So that once that completes, then it will be shipped to the wind farms for the final commissioning, right? After commissioning, once the data get into that, the commissioning phase will be over. Up to this will be the commissioning phase of the wind farm SCADA. I hope this will give you a bit clarity about how the new SCADA development has been made, right? As I said earlier, so now we'll see the functionality of the SCADA, right? So the key functionality of the SCADAs are data acquisition, network and data communication, and data presentation and control, right? As I said, in the normal automation layer, right, usually 5-stack automation layer is one of the best methods so far in the best practice around the world, right, for this communication. Out of these 5-stack layers, so first 3 layers, which is responsible, SCADA is responsible for the first 3 layers, right? So the third and fourth layer will come for the analytics and the ERP, MES layers, right? So for the SCADA, we don't bother about that. We just go through the first 3 layers. We will try to understand what are all the layers, what is the functionality of the layers, layer by layer, right? So if you see in the layer 0, 1 and 2, So layer 0 is responsible for the connecting the physical sensors which is available in the wind turbine or nearby wind turbine. So like multifunction meters which is installed in the transformer area. So that needs to be all the physical communications that needs to be terminated in the IO card or communication card of the PLC. This is the layer 1 responsibility. Maybe the layer 0 responsibility. Layer 0, what kind of sensors? Right, 4 to 20 milliamp sensors like PT100, KTY10, and digital inputs and outputs. Some alarm inputs we can read, and we can activate some outputs, and we can use some proximity sensors to measure the speeds, or we will detect the rotations. So these layers, any physical analog sensors or digital sensors which has been connected to the PLC, this is the layer 0. The layer 1 will be the decision making layer. The first level decision making layer, that is in a PLC, programmable logic controller. This is responsible for doing the programming, right? So we'll go into this detail, right? The first, data acquisition. What exactly the data acquisition? In the data acquisition part, all the sensors are physically connected to the sensor IO card in the PLC, right? Then the PLC is a program which collect the data in the various different interval, right? We cannot expect temperature to change in every milliseconds, right? This will take some time. We don't want to take the data quite often. That will create a junk in the data. So junk of data is, if the data is not varying, then if you are keep on taking the data in a high frequency, there is no use, right? So that's why the various sensor in different interval. This layers 1 and layer 0 are responsible for the data collection from analog and digital sensors. In some cases, we may connect some serial communications also, like RS-232 or RS-485 communications in the layer 0, right? That is the thing. And even it is responsible for high frequency data collection. Even millisecond data collection also will do. So that is also comes under this data acquisition layer. The next one is the network and data layer. This is the backbone of the Scada architecture, right? Without network, without communication, nothing will work out, right? All the sensors are connected to the PLCs or gateway to either Ethernet or serial connection. Most of the cases nowadays, everything comes under the Ethernet. Maybe in legacy SCADAs or legacy sites, we have some kind of serial communication like Modbus or RS-232 based serial customized communication. In those locations, we might use the gateways and converters to connect those serial connection to the Ethernet connection. So it is a general practice that any communications in the serial that needs to be converted into the TCP/IP at the least level. So that might help our method of troubleshooting, and it gives a lot of insights on in case of troubleshooting issues, right? So next, third and one is the data presentation and control layer, right? Layer 1 and layer 2. So this layer is responsible for converting this data, whatever the raw data which we are getting, right? So that data will be converted into visual dashboards and KPIs and notification. Because as an operator who is sitting there, he cannot go through the data, and each and every data he can understood everything, right? And it is not necessary to see all the 100 parameters or 200 tags. So for this operation, maybe some of the few parameters is very key parameters that needs to be displayed somewhere in the Scada, right? So that is the only parameter he is going to see. So for example, a simple operator is there. For his intention is he need to understand how much power is currently producing, how much wind speed is currently there, and is there any error is available on the turbine, or it is ready to run. Few parameters that needs to be displayed. For that only we are using HMI in the local Scada server. There Scada server will be the new screens will be produced it will show the normal key parameters and KPIs, how so far today how much energy has been produced, what is the downtime today, and is there any alarms are there, that kind of notification, everything will be available on this HMI, right? And also this layer takes care of the control algorithm like PI, PID loops and everything. This will do the algorithm and this will post the data to the PLCs to take the decision, right? So these are all the key functionalities of the Scada. So now I am going to explain about the how the WinFarm is connected in the fiber locally, right? So we usually ring connection we used. Here I showing you the star type of ring connection, right? Here in these WinFarms, all the wind turbines which is connected serially, but this will be here you may see the single line, but it is actually multi-core cable, and this will be looped every alternate machines, so that if any fiber cut happens, this will close in the other way, right? So independently this will pole all the turbines and simultaneously, because since it is running on TCP/IP, right? Then the multi polling will not be any issue. If it is in a serial kind of communication, definitely this won't possible. But since most of the turbines nowadays, most of the other OEMs are using the TCP/IP connection, that's why the fastest communication is possible nowadays, right? This is the example for this local monitoring. The operator who is sitting on the local Scada room, he can monitor all those turbines in the Scada. For central monitoring, so in some most of the cases we do monitoring the Scada from the locally, but in centrally also for taking some important decisions, and 24/7 control centers are there to suggest the operators on the critical situation and if any alarms are there. In such a case, so multiple wind farms, right? Multiple wind farms are connected through internet lease line to the hub. So it will create a tunnel. It will create a tunnel, and this will push and pull the data from the central location for the overall monitoring of all the wind parks, right? So this may be the regional control center, and similar to the regional control center, we might have global control center for doing the next level analysis, right? This will be connected through the secured VPN cloud for fetching sharing and fetching the data, and the remote central data centers are there to take the key backups of the parameters as well as the data which is used by the control centers, right? These are all will be stored in the central data centers. So this is the example for central monitoring with lease line connectivity. In this communication, the internet, we assume that internet is available, very good internet is available at the site. If in case, this is not true in all the cases, in some of the remote places, even we don't have the internet to access the wind turbine. In such a case, so we will do this kind of communication, right? So all we know, we have a 4G, very good 4G communication in across India, right? So in such a case, and we cannot expect the latency like ILL, but instead of nothing, we can use this. This is a secondary communication, right? For example, so the wind farms, here I am referring 4 wind farms are there, small wind farms. So these wind farms will be connected through a 4G VPN gateway, SIM based VPN gateway. That VPN gateway will be collected from the data collector, right? This will be the edge server or any edge IoT device which can sit over any states or any locations, and this will pull the data over cellular network. This data will collect the data from over cellular network, and it accumulates and pushes the data to the central server. It is similar to the earlier case, but earlier case we used the internet lease line between the wind forms to the data collection center, but the central location, the regional central location. But in this case, all the wind farms are connecting to the central data collection through the 4G SIM based this gateway, right? This is one of the cheapest method, but the reliable but we cannot expect the reliability as good as internet lease lines, right? So from the central location, we as usual will push the data to the QCS and push the data to the customers, as well as it has a backup copy in the DB servers, right? So next, the important part is what kind of data analysis we can do with the help of the SCADA data, right? This is the important and major thing what we are doing nowadays. So since we know all, we install the SCADA, right? We are our operator can see the some basic parameters through HMI. But apart from that, the main purpose of the SCADA is, as we said initially, monitoring, control, as well as data logging. Why we need to log the data, right? To analyze the data, right? Why we need to analyze? To identify the problems. What are all the things we need to store? Whatever the sensors available in the turbines, all the sensors need to be captured to analyze the problem. So for example, if the wind turbine having a 1000 to 1200 tags, all the tags needs to be captured. So inclusive of analog tags and alarm, warning and events, whatever it may be. So for that, why we are capturing those things? Then only we will do the analysis. Okay, now we'll see what are all the different tools available in the SCADA for data analysis, right? So the first one is the reports, trends and comparatives. These are the major three areas and the tools which used in the SCADA server, usually by most of the OEMs, right? The first and foremost is reports. We'll see the detailed about the each and every reports. In the under the report section, we have here, you can see that production reports, alarm warning reports, and 10 or 15 minutes reports. That is an analog report that which comes with average, minimum, maximum and standard deviation. And the next one is the availability. So what are all the availabilities available? So if you take the availabilities, general availability, energy based availability and time based availability, all those availabilities are there. We'll see one by one in detail, right? First we'll see the active power performance. What are the key things? I'm just trying to explain a bit more. So that's why I chosen this active power performance. All we know that PV curve, right? Any turbine, this is the most of the team, you also aware about that PV curves. So PV curve is nothing but we are plotting that curve with the help of wind speed and active power produced, right? So wind speed will be in the x-axis, and y-axis we are using active power, right? So by using this data, if you plot, you will be getting the curve will be, the ideal curve will be like this, right? So this can be plotted in our reports. The only thing what you need to do, you need to select the period in from and to date, right? If you choose on those limit, this report will consider the turbines, the 10 minutes data, which are all in the state of ready and run. For example, if sometimes in the 10 minutes the system in the emergency, it won't take for this PV calculation. So that's why I'm telling. So this will consider only ready and run state in the 10 minutes period, right? Okay. So and another important things is coefficient. right? Usually you know that power coefficient is 1.225 in most of the cases by default, but this can be arrived, and this will be arrived in the by the wind team by installing the medmast. They will already pre-calculated values will be there. In the Scada we have a provision to configure the this CP value in the Scada page. So based on this value your power curve will be plotted. Next one is AWS, that is alarm warning and status. This is one of the key report which used for by most of the analysts. This will give the lot of insights in case of issues, right? So whenever things goes wrong, the people will always take this report and do the analysis, what type of alarm and sequence of alarm they will capture, right? This sequence of alarm is very much important, since we know this is not a periodic interval kind of thing. Whenever there is alarm, this will push their alarms to the Scada server, and Scada server will store the data in the possibility of change in state. So until there is no change, it won't store the data, because this is in a AWS data. If it is in a 10 minutes data, then it will store the data periodically. That we'll see in the next slide, right? This alarm warning will be grouped by based on the WinForms, and if in the normal alarm warning reports, you will find the WinForm name and device name and category. So what type of category this is, whether it is an alarm, whether it is a warning or a states, right? Even you will get the code for those all the three divisions. Like alarms, you will have a code, and warnings and states, you will have a codes. So through that code, in case in future you may go and search in the through ODBC, that code will help you on that. And the event start time, end time, and how much duration this event was active, and what is the description for this event. So these kind of information you can able to download it through this AWS analysis report, right? And this is also where it excludes the samples other than ready and run. Excuse me. Okay, so another key thing is X-minute report. We commonly tell it as X-minute reports. It means that 10 or 15 minutes reports, right? So usually in wind industry, this is the practice that all the data will be averaged in 10 minutes or 15 minutes interval, right? So the minimum achievable polling frequency is 1 second in case of small WinForms. Small WinForms in the sense, if the WinForm is it depends on the OEM, right? So in our case, if our WinForms is less than 25 turbines, then 1 second is possible. So polling of each and every turbines in 1 second, and we can do the average for 10 or 15 minutes. That is customizable. You can even, in some cases, you can need the both also. You can choose both the experimental values, and you can do the download the data. So this is the data. 10 minutes data is 10 minutes or 15 minutes used for the all kind of analysis and the calculation methodologies, right? So in this report, you can go and select the device type. So what is the turbine you want to select, how many turbines are there. So sorry, whether you are going to collect the turbine or UPS or some other devices, which device you want to collect 10 minutes data. And out of these device types, if you go and select the which turbine you want to do this analysis, right? That once you selected and give the to and from date, and you can mention here in the frequency. So here you can select 10 or 15 minutes. Once you select the 15 minutes or 10 minutes, that respective data will be downloaded. You can select the number of tags. Here these tags are available In most of the cases, each and every turbines have almost more than 100 to 200 tags, right? So all the parameters will be downloaded and for the analysis. So this is one of the important and key tool for downloading the data for analysis, right? So up to tools this reports. Then we'll get into the availability, right? Availability is also the important analysis. So coming to the availability is general availability. So how this general availability is referred here is whenever the wind farms is available for technically available. Technically available is referred as turbine OK hours divided by environment OK hours. What is turbine OK hour? Turbine OK hour means if the turbine is in the ready mode and you can ready to run at any time. So if the wind is in the favorable condition, then it is ready to run. Until wind is not favorable, this will be in the ready mode, right? That is turbine OK hour. And environment OK in the sense, so environment should be in favorable, right? For example, if the wind speed is not less than 3, is less than 3, it is not favorable for generating the power. And temperature should be in the allowed limit. This should not be more than 45. So because more than 45, turbine won't run. So that is an environment. If that is the case, environment is okay, means all the environment conditions are within the limit. And turbine OK hours means turbine is ready to run. Absolutely, there is no breakdown or anything. And what is the environment OK hours, right? So these things you can be downloaded in the report and for the further analysis. So general availability is up to based on the contract also, right? And energy based availability, this is the one of the key things nowadays, very familiar. So the availability will be calculated based on energy. So in this report, the production and energetic availability on the requested period, we need to select the period, right? We need to select the period, and on that period we will be able to get the energy based availability, and the losses will be calculated. Losses will be calculated based on the IEC 6140026 algorithm, right? So EBA equal to produced energy divided by produced energy plus losses, right? Energy based availability will be calculated produced energy divided by produced energy plus losses. These losses will be calculated based on the IEC algorithm, right? So you can see the trend. You will be getting the reports like this in the trend graph. Okay, so this loss calculation maybe it depends to the contract also. So we generally will be calculated based on the algorithm, and if any further things also, it's decided by the contract. And time availability. Time availability in the sense how many hours it is ready to run. So that availability is very much important, right? So this availability will be calculated based on the time ready to run, and you can also create a report by selecting those respective turbines and the respective periods. You can if you choose those period, you will able to see the report this kind of reports. How many hours is turbine is available for the generation, and this loss is also calculated by the categorization type. Right, coming to the trends. So once we are completing the first part of the reports and coming to the trends, trend is one of the key feature where we can go and select some particular parameter for a given period like month or year or something. We can plot that parameter to analyze, to visualize the variations in the values, minimum and maximum, everything we can see, and we can export that value as a Excel or a CSV. So here we have advantages. We can fetch the data in least pole interval, that is 1 second interval. In 1 second interval we can plot the value and we can fetch the value. This is quite helpful in case of if you find any sudden spikes in the values, that you can able to get it only through the instantaneous value. You can't get it through the 10 minutes value because that will be averaged for 10 minutes. Okay, so this is the one of the best tool to export this 1 second data and the least kind of data through CSV files. Okay, so WTG comparative, this is also another very good tool. If you want to analyze some parameters with the nearby turbines or within the turbines, within the wind farm, you want to compare the particular parameter with between turbine to turbine. In that case, you can choose the turbine and the parameter, which parameter you want to compare. If you choose those parameter, the difference you can able to easily find out, right? In the same wind farm, almost the wind speed will be same, but in some abnormality you find, and is there any power reduction, then you might use this tool to identify the problem where exactly, right? This is a very good comparative tool. And another interesting part is here the open interface and the cloud protocol. See, all we know in the industry 3.0, so we are doing the collection of data and the data is available at the wind farm level. But now world is moving towards the 4.0. So that's why now people are more interested on cloud and other kind of data collection methodologies for analysis. In that case, we need to understand what kind of protocol that Scada supports for transferring the data to the cloud protocol, right? This is key and important things in current scenario in industry 4.0. So everybody knows in the industrial revolution, as we know, the first revolution is a mechanization, second revolution is in this automation, right? Mass productions and using electrical engines, that is in a second. And third one is in a robotics and PLC and these kind of devices, and Scada, these kind of devices has been invented for the local controlling, right? But now world moving towards industry 4.0, and all the data needs to be collected centrally in the cloud, and the machine learning and artificial intelligence should be used for the over the data to identify and to can minimize our issues and predict and proactively predict the issues and proactively. That is the intention for all the world to fetch the data from the Scada, right? In that scenario, we should know what are all the common protocols which is available in the wind industry, right? Most of the Scadas will support the OPC, right? So OPC, there are 3 different kind of OPC protocols which is available in the market now: OPC DA and OPC UA and OPC HDA, right? OPC DA is OPC direct access, and OPC UA is an unified access. So difference is if you in a brief, that OPC DA is a less secured methodology. So most of the time the DA is preferable if you are using that OPC connection within the wind farm. In that case, you can use the OPC DA. But OPC UA is an secured method, and you can connect the Scada server from remote anywhere from the world, right? So this is highly recommended for the cloud kind of communication, for real-time data communication, because in OPC standards we always have the quality of service, right? Quality of the data. So that is very much important. If you let us assume that we are taking the data from the Scada server and we are getting some data and we don't know whether this is live data or not. In the OPC protocol itself, there is a functionality called quality. If quality is 192, it is good. That is a standard. So if it is other than 192, you can ignore that value. You may get the value. That value may be the previous value, or if the device is restarting, that time we may get some junk value. For example, if you are, let us assume that we are fetching the temperature sensor data through OPC. For example, if PLC is restarting and in the initial restarting sense itself, the TCP/IP socket will be up, then it will immediately try to fetch the data of the temperature sensor. So this may not be correct value, right? Because PLC itself restarting now only. Then it has to apply some kind of algorithms and it has to send some calibration values to the sensor, and then only you can able to fetch the data. In the meantime, we will start buffering the data. PLC is supposed to give the data, right? That's how the algorithm will be there. But we know that data may not be the actual value. We have to wait for some time. Maybe the dependency of the sensor. So in that case, in the OPC, we will not get the 192 quality till the sensor is ready, right? That advantage we have. That's why OPC is the powerful real-time data access tool, right? So OPC DA and UA usually people used in the real-time data access. Even in the OPC DA case also, people using OPC tunneler for the secured data access. That is an additional software. So better to go with OPC UA instead of DA. That is our advice. Right. So the next one is the legacy, but nowadays very commonly used protocol, that is FTP, file transfer protocol. As we know, the real-time data we are sharing through OPC DA or UA, but the 10 minutes CSV files, that will be, the file needs to be pushed to the either the central location or the forecasting agencies or the customers who are all needed those data, the 10 minutes data for the further analysis, right? In such a case, FTP is the current mechanism people are using now widely in the wind industry for getting the data, right? ODBC is the another method which commonly most of the OEMs sharing the data sorry, excuse me sharing the stored database stored with the data. Usually they have a stored procedures, that procedures will be given as like ODBC procedures, right? Through that we can fetch the data and we can collect the data from the commissioning date. But the limitation may be you can fetch only one data at a time. So that may be the limitation, but it is a very powerful tool. You can access data directly from the database. So the fifth one, I'm just covering other three protocols that may not be used for a regular WinForm application, like data sharing to things. But most of the devices like meters and Metmust controllers, those things still they are using Modbus TCP because of the simplicity. Most of the TVM meters, trivector meters, multifunction meters and Metmust devices are still supporting the Modbus because of this simplicity. You can pull the data over TCP/IP network and you can fetch the data, and the payload is very small, and this is very quite fastest protocol. You can get the data in milliseconds, right? If you send a query to fetch 50 bytes of data, you will get those data in 50 milliseconds. So just assume that how much fast it is. So that's why still the Modbus is familiar in most of the industries in India as well as in the other part of the world. The next one is the IEC 61850. So this one, people you might aware that this is very commonly used in the substation relays, smart relays. They are using 61850. These relays can be integrated to the Scada to fetch the data, right? And the SCADA, the same SCADA can be shared to the load dispatch centers. Most of the electrical smart equipments can support this 61850. And another one important protocol, usually this is used in case of SLDC communications. Most of the state load dispatch centers and central regulatory agencies, they are fetching their data through the IEC 104 protocol. So there is an important protocol nowadays. That's how all the substation data has been shared to the state load dispatch centers, right? So this is the physical layer protocol which has been used in the wind farms, and some of the key protocols which others web-based protocol also there, that is an HTTP, all we know hypertext transfer protocol, and WebSockets. This may be the customized program you can write on your own, and you can establish the communication over TCP/IP WebSockets. These two also probably widely people are using to sharing the data, because HTTP, all we know that RESTful API you can get or set. So HTTP command, get command and put command, that you can use it. Even in the IoTs, people are using that HTTP in the different format, that is co-op. Probably you may, if you get into that IoT kind of thing, then you might aware about that HTTP and co-op. Right, up to this, these are all the very familiarly used interfaces and protocols. So in the WinForm to cloud communication, right? So most of the interfaces, physical interfaces, TCP/IP is the major interface. Without that, we cannot transfer the data over internet. So the physical interface is TCP/IP for all those things, and this in the application layer you can see that this is the protocols widely used. Maybe so some few of them they can use their own protocol, right? So I'm just covering the overall protocols which widely used. So just to share this in a pictorially, right? Here you may have a Modbus communication or IEC 61850 communication or 104 communication. So once DAQ fetch the data, then this data will be available in the OPC DA server, right? Here in case of this is the server and this is the client, right? The client will fetch the data from the OPC, and this can do some kind of computation to create this CSV file. Once the CSV file is created, this FTP can be pushed to the internet cloud. There then once it reaches the internet cloud, then it is matter of the analytics engine, right? So they will do their model based on their experience and domain expertise. They will do the models, right? In this case, the important thing is the client server concept only. Here we are using this OPC client. The external will be the client. He will establish the communication first with the server, then it will fetch the data from the server, and this will create a CSV file and push it to the analytics team. Right, so this is the pictorial view of representation for how the connectivity between WinForm to the cloud communication. And I'm just to referring what is the latest thing which is in the WinForms now, power regulation, right? PPC. That controller is it's familiar now in across India. Now they started, most of the WinForms started using this power regulation tool. Even in all the new secure projects has been mandatory for this power regulation, active power. There are types of power regulations which is available: active power, reactive power, voltage, frequency, and power factor regulations are there. Most of the cases, reactive power regulations widely used across India. And the recent regulations is it's to come that fast architecture. So fast architecture in the sense, the legacy method of power plant communication. This power plant communication is minimum achievable frequency is 1 second. So that means that we can able to fetch the value from the vectors within a second is the least. But in the fast architecture, you can able to get the data and take a decisions based on 200 milliseconds. So that means that 5 times lesser compared to the earlier one, right? So obviously this is in a fastest method, and you can take the decision 5 times faster, right? That is the key thing. And so the latest things, evolving thing is a hybrid in the industry, right? Hybrid in the sense using the same evacuation substation, we are using the wind turbine as well as solar, right, to utilize to effective utilization of the substations. So as we know, in India we have a very less period of maybe 6 months we have a wind, and another 6 months we don't have wind, right? A low wind season. In that case, probably we may use if we installed a solar panel over there, we don't have any limitation on getting solar light, and especially in India, in across throughout the year. So we can use the same evacuations, and we can use the solar as for pumping the power. So harvest the energy from the mother nature, and we can pump to power to the world, right? So this is the basic architecture, and wind plant is here and solar plant is here. So substation is there. There is a curtailment regulation mechanism is there. So basically there are three priorities we usually consider for this hybrid, and that is a wind priority, solar priority, and hybrid priority. What it means, right? So if in case of this is the high wind season, in that case we don't want to harvest the power from the solar, and we want to harvest the power from wind. In case of these PPAs and different for wind and solar, that decision can be taken based on that which one we need to operate, whether we need to operate a wind and which is the advantage for us. So that decision will be taken based on these priorities. So if it is in a wind priority, wind will be the taken as if the maximum evacuation is 50 megahertz, and we have 30 megahertz for wind and 30 megahertz for solar. If the maximum power production reaches above 50, then if you choose the wind priority, solar will be curtailed. And in the solar priority, other way, right? The wind will be curtailed. In the hybrid priority, that will be based on the decision taken by the hybrid the controller itself, because which is the feasible, which is the stable, and that decision will be made by the controller, right? This is the key things, new thing, and which is evolving. Even other part of the world, they are using the batteries for store those energy, right? So this is quite interesting, and which is evolving in industry. So we'll see. So we expect some more hybrid plants in India. So we'll learn from that, right? Right. That's it. My presentation. So you can end of this presentation. We'll have a Q&A session. So I'm eagerly waiting for your questions. I hope I can able to answer most of the questions. If it is not, no problem. I'll get your questions, and I'll reach you. I'll send my response on any time through the medias, right? So if you want to reach me in the LinkedIn, this is my LinkedIn profile, and you can reach me at Kudiyarsu in Twitter, and you can write me if anything want to understand. You can write me in kudiyarcm@gmail.com. So you can reach me through phone. So I'll try to I hope I can resolve your ideas up to my knowledge. So that's it, team. Thanks for joining with me, and we'll discuss in the Q&A session.